Can everyone see my screen?
Yes, perfect. So then once you start your presentation, we'll start the timer.
Okay. As we know, exploring protein sources to alternative animal proteins has been at the forefront of food ingredients innovations. So in recent years, pea protein athletes has received increasing attention because of the competitive prices and valuable functionalities. With respect to its functional properties, foaming capacity is one of the most important functionalities which is closely related to its application in food industry. Globulin is the major storage protein in pea. It can be divided into two fractions according to the sedimentation coefficients. They are vicilin with a trimer structure and legumin with a hexamer structure. According to one of my previous studies, compared to the total globulin in the legumin, the foaming capacity of vicilin was outstanding because of the high solubility and less rigid structure. However, despite this, as a plant protein, the foaming capacity of pea vicilin still compares unfavorably with some animal proteins such as egg, white, and casein. Therefore, the aim of this study is to physically modify pea vicilin by pH shifting, heating, and ultrasound treatment in order to improve the foaming capacity. So following is the result. I firstly did the foaming test, and I was so excited to find that compared to pea vicilin control, all of these individual physical treatments improve the foaming capacity, especially heating treated samples. Its foaming capacity was even more superior than that of egg white and casein. To find out the principle of this improvement, I did the HPLC SEC mouse test next. It was clear to see from that chart that both pH shifting and heating treatments created more soluble protein aggregates. But how did these aggregates improve the foaming capacity? I did a dilutional rheology test. Firstly, a droplet of protein solution is formed in air. The protein from a bulk solution diffused to the air-water interface and form a protein film at the interface. During the measurement, the interface area of that droplet is changed sinusoidally in 1.5 hours. The dilatational elasticity of the protein film can be calculated according to the actively changed surface area and passively changed interfacial tension. So we can show this figure. From the result, we can clearly see that the dilatational elasticity of heating and pH shifting treated samples are higher. So that means protein with more aggregates can form a more elastic film, especially heating treated sample. So that may be the reason why more aggregates improve the foaming capacity. Okay, that's all of my sharing today. Thank you.
All right, good job.